Yeah, shout out to Liz. Anyways, it's posted in Schoology, and when we're all done with this, I'll post the actual written document. So to pick up where we left off, we're talking about precision and accuracy, and so this is a critique reasoning. A student claimed that 0.045 and 0.0045 meters have the same number of significant digits. Is that true or not? Do you agree or disagree?
I disagree.
Well, remember, the first thing we've got to do is count the non-zeros, right? Those are significant. All right? Non-zero. So I've got 1, 2, 1, 2. Now remember, anything to the left, right? Well, here, let me just write it out because so they are two significant figures. Okay? Actually, yeah. So agree. And here's the reasoning. Zeros to the right don't count. Right of the decimal. And I shouldn't say they don't count. I'll word it a little better. Decimal count only if they are either to the right of the last non-zero or if they're wedged between non-zeros. Or we'll say sig figs. All right. So, in other words, if I say 0.0045, it doesn't matter. I'm only counting these. That's two significant figures. But if I say, so this is two sig figs. If I say 0.000450, now because it's to the right, that's three sig figs. Now, if I say 0.4005, because the zeros are trapped between the significant figures, that's 4 sig figs. Okay? Does that make sense? So let's do number 6. How many are there? Well, these are the significant figures, so that's 2. Now this one, there's only 1. Zeros to the right don't count, so that's just 1 sig fig. This one has 1, 2, 3, 4. They're to the right of a decimal, so and they all follow a non-sig fig. So this would be a total of 5. Now this one's a little confusing. The question sometimes students will say is, well, do I include this one? Yeah, you go from the front to the back. So we're including all of these. Okay. Let's move on to example number 3. In example number 3, it says, when performing calculations with measurements of different precision, the number of significant digits in the solution may differ from the number of significant digits in the original measurements. Use the rules for the following table to determine how many significant figures to include in the result of each calculation. I'm going to teach what the book teaches, and then we'll talk about what Mr. Adams thinks is acceptable. This is always controversial. You know, when I did research at Northwestern, I had a long conversation with one of the professors there about significant figures. And basically what he told me is that he only worries about the least, he's more concerned with the decimal measurement. In other words, if I measure to the thousandths, he wants me to round to the hundredths. That's what the conversation he had. That's a lot easier to remember, and with regards to this stuff. But we'll read this because this is what the textbook says, and it'll probably be on the SAT in some form or fashion. It says, for addition and subtraction, the sum or difference must be rounded to the same place as the last significant digit of the least precise measurement. So if I have two measurements and I say 1, 0, 5, right? Well, that's three significant figures, but it only goes to the hundredths, right? So this goes to the hundredths. So I would round to the tenths. But they're saying you would round to the hundredths, okay? Multiplication or division, you do all the multiplication and division, but then no more significant digits than the least precise measurement. And what that boils down to is, especially with multiplication, if I'm going to have some decimals, when I multiply decimals by decimals, I can get crazy numbers of decimals. Oh, sorry. I can have 4 or 5 decimal places after the decimal point, and I have to remember what the least precise measurement was. So let's just look at some numbers and see if it makes more sense. So when I look at example A, it says a rectangular swimming pool. This is our little rectangular swimming pool here. See it?
That's a big swimming pool.
Yeah, it is pretty big, isn't it?
Yeah.
That's the swimming pool. All right. So they're saying that the pool measures 22.3 by 75 feet. Now this, the least precise. This is the least precise because it only goes to the ones place, right? 75. This one goes to the tenth space, but this is the least precise. So when we go to find the perimeter, we do a bunch of adding and subtracting. So I'm going to add this, I'm going to add this, I'm going to add this, and I'm going to add this. Now, even though this is the least precise, this is 3 significant figures. But it's also the, we can feel confident with our answer, so we go to 1/10. We calculate the answer to the tenths, okay? Now, the least precise measurement is 75 feet, and the last significant digit is in the ones place, which is what I said. So, round the sum to the ones place. In other words, even though the calculation is 194.6, I need to slow down. We're going to round to the ones because that's the least significant, okay? Now, if we do the area, because we're cranking through the math and we multiply this, same thing. 75 feet has 2 significant digits, so we're going to round the product to the number of 2 significant digits. So that's an interesting one. So I've got 1672.5. Okay, this is where the textbook of Mr. Adams differs. They're saying 2 significant figures would be these first 2. Well, that's in the hundreds spot, so I go to this number. 7 means I'm going to round up, so it becomes 1,700. So they said the area is 1,700 feet. My good friend at University or Northwestern, he would argue that we would round this to 1673. But you're multiplying the error. So if there's an error, you're multiplying the error. Sort of. So anyways, let's do what the textbook says. So let's do the math on this one. So the sum of this is going to be 21 plus 25.2. So we're finding the perimeter of another rectangular shape. 21 plus 25.2. Now add all those up on your guys' calculator and tell me what you get for the final answer, please. I think it should be 92.4, right? Well, the least precise measurement, though, is 21 feet. Right? This is the least precise. So that means we're going to round to the one space. or place. So then the perimeter would be what? Well, I look at 92.4. I look at the number to the right of the 1 space. Remember, we're rounding to the 1s. 4 is less than 5, so we're going to round down. So the perimeter then would be just 92. And it's approximately 92 because we're rounding. The area is the length, right? And so for the length, we could say 21 feet. I probably should put the units in there. By 25.2 feet. So then my answer will be 529.2 feet squared. Okay? 529.2 feet squared. The least precise measurement is 21 feet. And that has 2 significant figures. So round to a number of 2 significant digits. So then we look at the first 2. So we're rounding to the tens. So 9 would mean we round up. So the area is 530 feet squared. Does that make sense?